Hello friends, in this video I'm going to solve problems on first law of thermodynamics applied to closed system. During one cycle, the working fluid in the engine engages in two work interactions, 15 kilojoules to the fluid, that means work is done on the system, and 44 kilojoules from the fluid, that is work is done by the system. And three heat interaction, two of which are known, that is 75 kilojoules to the fluid, that is heat added to the system, and 40 kilojoules from the fluid, so heat is rejected by the fluid. Evaluate the magnitude and direction of the third heat transfer. So here it is clearly given that Q1 plus Q2 plus Q3 equal to W1 plus W2. So now let us list the given data. Here W1, first work interaction, is 15 kilojoules to the fluid, so W1 equal to minus 15 kilojoules because work is done on the system. Then W2 is 44 kilojoules, it is plus 44 kilojoules because work is done by the system, and there are three heat interactions, out of which two are known, and third one is to be calculated. Its magnitude as well as its direction has to be calculated. So here Q1 is 75 kilojoules. Now let us see its direction. Here 75 kilojoules to the fluid, so heat added to the system is taken as positive, so it is plus kilojoules. Then plus 75 kilojoules. Q2 is there will be 40 kilojoules from the fluid. From the fluid means heat is rejected by the fluid, so heat rejected by the system is taken negative, so it is minus 40 kilojoules. So now let us substitute the values to this equation, first law equation, so that Q1 is 75, then plus Q2 is minus 40 kilojoules, so let us take it minus 40, then plus Q3, it is not known, that Q3 is to be calculated, so that is equal to W1 is minus 15 kilojoules, then W2 is plus 44 kilojoules, then the value of Q3 is equal to minus 6 kilojoules. Here minus 6 kilojoules means heat is rejected by the fluid, so heat transfer takes place from the fluid. Here heat transfer is from the fluid, or it is from the system. Then in the next problem, that is once again on first law of thermodynamics applied to closed system. In this case, a domestic refrigerator is loaded with food and the door is closed. During a certain period, the machine consumes 1 kilowatt hour of energy, and the internal energy of the system drops by 5000 kilojoules. It is dropped by 5000 kilojoules. Find the net heat transfer for the system. There is a domestic refrigerator that is run at the rate of 1 kilowatt for 1 hour. To convert this 1 kilowatt hour to kilojoules, it is done in a simple way. That is consumption of here it is electrical work. It is electrical work. So that work is equal to 1. It is kilowatt hour that is taking place. 1 kilowatt that energy transfer rate takes place for 1 hour. So it is 1 kilojoules per second into, to convert this one into hour, this should be multiplied by 60 into 60. The first multiplication of 60 will convert it into minute, that is kilojoules per minute, and then another multiplication of 60 will convert it into kilojoules per hour. So for 1 hour there will be 3600 kilojoules of work transfer, electrical work transfer takes place to the refrigerator. In doing so, there will be 5000 kilojoules of this heat that internal energy is dropped. So here delta E is dropped by minus 5000 kilojoules. It is minus 5000 kilojoules. Now let us apply first law of thermodynamics to calculate the net heat transfer for the system. So here it is Q equal to delta E plus W. Here delta E it is reducing, it is decreasing, so it is minus 5000 kilojoules. Here work is done on the system, electrical work is done on the refrigerator, so this is also negative, it is 3600. So the net heat transfer is minus 8.6 megajoules. So the net heat transfer is calculated now. It is minus 8.6 megajoules. That is heat transfer takes place from the refrigerator, from the system.